So in the last few days, a lot of press has been discussing the same story. The story about a potential discovery of atmosphere around a planet that's in the habitable zone of its parent star. Although in most cases, it was essentially reported as this: the first atmosphere around an Earth-like planet. A planet that we've discussed previously, referred to as LHS 1140b. And so because of this buzz in the news, and because technically this is a groundbreaking discovery, I wanted to talk about this as well, discuss exactly what the study is about, but also discuss certain misconceptions that were reported in certain press releases. But first, let's talk about the planet itself, how it was discovered, and of course discuss the overall astronomical research when it comes to exoplanetary atmospheres. And that's because generally, even though we discovered and confirmed thousands of exoplanets, there's actually been this major roadblock. The roadblock when it comes to smaller planets, specifically terrestrial planets, and figuring out if they also have atmospheres, or if this is actually something that's more or less unique to the solar system. And that's because most of the confirmed atmospheres so far have been discovered around much more massive and much larger planets, such as the famous hot Jupiters, that are technically nothing like planet Earth, or even like our own Jupiter. These were unique planets that existed in many other star systems, but that just do not exist here. But for almost a decade now, researchers were basically focusing on this star system. The system known as TRAPPIST-1 that contains 7 confirmed terrestrial planets, with some of them even located in the so-called habitable zone, where we kind of expect liquid water to potentially exist. But despite many different observations and a lot of different studies in the last decade, so far, even here, nothing has been confirmed, and the 2 closest planets, planets B and C, do not seem to contain anything. Or basically so far, they seem to be more or less barren. You can learn about the observations by the James Webb Space Telescope and the studies about this in some of the previous videos in the description. But on top of this, in the last decade or so, based on many different observations, scientists have also discovered quite a few exoplanets that seem to be inside habitable zones of their home star systems, and that potentially have a chance for liquid water as well. There are 45 exoplanets in this particular image, and well, one of them is the one we're discussing today. Because it looks like, for the first time in history, researchers have confirmed an atmosphere around one of these planets that are not that far away from us, making this a very important milestone. But in this case, let's not make any assumptions, because this was not a breathable atmosphere, and there are actually still a lot of unanswered questions. And so let's discuss exactly what was found, and of course discuss why this specific world is technically nothing like planet Earth. And so let's discuss LHS 1140b. And intriguingly, compared to many of these other planets, this is one of the closest to us. So the TRAPPIST-1 system is approximately 40 light years away, and this one is approximately 49. In galactic terms, this is basically our cosmic backyard. But unfortunately, just like the TRAPPIST-1 system, this one is also orbiting a red dwarf. And as we've talked about in previous videos, unfortunately red dwarfs are not the best homes. Mostly because they're known to be quite violent and often blast their planets with very powerful radiation that tends to strip atmospheres almost right away. Which is what scientists now believe might have happened to the TRAPPIST-1b and TRAPPIST-1c. But luckily for us, LHS 1140 is also believed to be a more or less quiet star. Despite being a red dwarf, and despite being 1/5 the mass of the Sun, it seems to rotate pretty slowly once every 130 days, and thus does not contain a powerful magnetosphere, preventing it from releasing a lot of powerful flares. And so it's very likely this stability that actually allowed this planet to potentially develop something on the surface. But there is a very important but. Like I said, technically this is not a terrestrial world. This is a super-Earth. In other words, this is a much more massive and much larger planet than Earth, and potentially contains a lot of different properties. As a matter of fact, this is a type of a planet that does not exist in a solar system, but exists in many other star systems out there. And this is also very different from anything we've seen in the TRAPPIST-1. Here this is about 5.6 masses of planet Earth, and is also about 1.7 times larger. In contrast, a lot of TRAPPIST-1 planets are actually kind of similar to Earth. And originally this planet was discovered by a mission referred to as M-Earth. And so back in 2017, this project used a transit method to basically discover a tiny dip in brightness in front of the star, with this particular transit becoming really exciting because almost right away it was confirmed to be in the habitable zone of the star system. And so even back then it was already considered to be a prime candidate for life. But once again, even though this is potentially a rocky planet, essentially it contains a terrestrial surface, it's not exactly Earth 2.0 yet. As a matter of fact, it seems to receive only half the sunlight Earth gets, and could thus be potentially extremely cold. Although when it comes to exactly what the surface is like and what the temperature is like, that's not something we know yet. But here's what we do know, and here's what this study was about. And actually it's the title that tells you everything. Helium. Helium escaping the atmosphere. And so here the study does not claim to discover actual atmosphere, but only signs of helium escaping from the planet. And that's of course the important part. Because even right now it's incredibly difficult to try to image the atmosphere of these planets because they're just so small and the atmosphere is so much thinner than around a typical gas giant. But a few years back, the main researcher behind the study, Colin Cherubim, came up with a model where he actually described a phenomenon referred to as atmospheric fractionation. Or basically, over billions of years, intense radiation from the host star starts to heat up the planet's upper atmosphere. And this causes lighter gases like helium reach escape velocity and basically escape into outer space. But slightly heavier elements, including helium, can actually be left behind in much greater concentrations because they do require just a little bit more energy to escape. And so originally, this model predicted that some of these planets with somewhat active stars may contain upper atmospheres that would be heavily helium-dominated and hydrogen-poor. But this now had to be proven, and that's exactly what was done in this study. Using the wine-red spectrograph on the Magellan Clay Telescope in Chile, researchers watched a planet transit the star in September of 2024. And as the starlight filtered through the edges of the planetary atmosphere, they noticed a tiny dip in light at the exact infrared wavelength that helium usually blocks, which essentially confirmed this cosmic leak phenomenon. And because helium is generally pretty light, on smaller planets like Mars, it simply drifts away immediately. And so in order for helium to be present here and to be detectable, LHS 1140b had to contain thicker, multi-layered atmosphere that's actively being heated by stellar X-rays. Otherwise, it would not make sense why helium was found here. And interestingly in this case, researchers also looked at the partner of this planet, 1140c, which is a little bit closer to the star, and they found no helium on that planet at all. And here's a rough artistic representation of how these two planets compare to planet Earth. And that potentially implies that the closer planet had a lot of its atmosphere, if not all of its atmosphere, stripped away, while the second planet, the larger planet B, managed to hang on to its atmosphere for at least 3 billion years. But even here things are still not entirely clear because this signal was only visible once. And specifically, while the helium signal was pretty clear in 2024, when the team looked again in 2025, the signal was gone. With this kind of variability being just a little bit surprising, although it doesn't mean that the atmosphere suddenly disappeared. Instead, now scientists believe that helium is only detectable from Earth in its excited state and not in its neutral state, which means that the atmosphere might be responding to changes in the star's magnetic activity. Or just to rephrase this, the atmospheric leak is still happening, but in this case the conditions were just not right for the telescope to observe helium the second time. Or at least that's the conclusion for now. We obviously need additional studies and additional observations to definitively confirm these findings. But then there is the more important question. So what exactly does this tell us about this world? Or basically, what exactly is this planet and how likely is it to contain life? Well, based on a lot of previous models, scientists assume that by this stage in life, most of these planets should already lose all of their helium and all of their hydrogen. In other words, if there is something here, it should not be helium and should be something else entirely. At least when it comes to planets of this size. But in this case, because helium was discovered, it essentially suggests that LHS 1140b might be going through its transition period. Or just to rephrase this, it's basically evolving from some kind of a smaller gas giant, like some kind of a mini Neptune, into a much more massive rocky planet, many of which we've discovered in the past. And that's actually a really important discovery and a very important confirmation, because it potentially explains a kind of a mysterious gap when it comes to various mini-Neptunes. This is sometimes referred to as the Fulton gap or radius gap, and is basically a kind of a statistical scarcity of various planets between about 1.5 and 2 times the radius of Earth. In other words, there are quite a lot of planets that seem to be 0.5 to maybe 1.5 radii of Earth, and there are even more planets that are 2 or more radii of Earth. But for some reason, there was always this unusual gap right here. And it was previously suggested that this was because it's essentially a transition stage. Or basically, at this point, a lot of these mini-Neptunes start to lose a lot of their gas and then transition into a kind of a super-Earth as the final product. And that's possibly exactly what we're seeing here. It's essentially a kind of a transition stage between sub-Neptune and super-Earth that's not purely rocky yet. And so based on some of the refined measurements of its density, there's a very high chance that its surface is actually not terrestrial and instead might contain a huge ocean, or possibly even an extremely thick atmosphere covering a much smaller rocky center. In other words, it's once again something extremely exotic and something we don't really understand. But once again, if we compare this to the TRAPPIST-1 system, it's also extremely different. In this case, the density of these planets does seem to resemble a rocky world, and so these are still just a little bit more exciting. In contrast, LHS 1140b is definitely quite different, but is still the first officially confirmed exoplanet in the habitable zone that seems to have retained its atmosphere. And it also potentially validates a new class of planet that the lead researcher is now calling the Helium worlds, or basically planets that have lost their hydrogen but managed to keep their helium, creating a somewhat unique type of environment that once again we cannot imagine just yet. And yet trying to talk on this world will make you sound very squeaky. But when it comes to astronomical discoveries, this one is also important because it was actually found and confirmed by a terrestrial telescope and not a telescope in outer space. In other words, we don't always need to have space telescopes like the James Webb in order to discover or characterize exciting exoplanets, and in order to find the atmosphere around them. Okay, so what's next? And also, what's the actual conclusion here? Well, once again, to be clear, nobody is saying right now that this is a habitable planet and that it has any chance of containing liquid water or alien life. Because right now the only confirmation is an extremely thin upper atmosphere that seems to contain helium, but the presence of oxygen, carbon dioxide, or water vapor has not been confirmed. For all we know, this is a very hostile place where everything just sounds super squeaky. But the fact that a rocky planet orbiting a red dwarf can actually have atmosphere is definitely a really exciting discovery for astronomy in general. Because here it means that even red dwarfs, in theory at least, can still maybe contain habitable conditions, and might even contain conditions where liquid water can form in at least certain regions. And so the next step is obviously going to be the observations with the James Webb. And that's because scientists now want to find heavier gases like nitrogen and carbon dioxide in order to discover what the atmosphere might be like. Which means that LHS 1140b, at least right now, is definitely the most important target when it comes to exoplanetary research. And it might also help us answer the question of if these planets can be habitable and if they can actually contain liquid water. But at least for now, that's all we know. Once we discover something else, we'll come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else. Support the channel on Patreon where you can find additional videos without any ads and can DM me directly, or by joining a channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.